All right, so quiz 6, we got 3 different units on it, so let's get into it. The first one is going to be linear approximation. It's relatively straightforward. You're basically just going to be using this formula several times, but the questions can get a little wordy or confusing, so it's important to know how to handle them. So if we have a question like this, the gist of all linear approximation problems is we're trying to identify 3 things: an f of x, an x, and an a. And it's not always incredibly straightforward, but I would say the f of x is generally the easiest thing to pick up, particularly on a problem like this, where it literally tells us y equals the cube root of x. So problems where it tells you f of x equals this or y equals this, that's kind of just giving it to you. It's the function that you're going to be plugging in everything to. So, and then it's telling you at the base point x equals 27. That is actually going to be our a, because our a is what we make the, like what point we make the approximation at. And then our x is actually going to be 29, which we have here. So here, I'll color code it a little bit. So this is where we get it from. And this is kind of the tricky part. And you kind of just have to get the feel of it and do some practice problems with it. But you can kind of think of it like a is, right, so we're taking a jumping off point. We're taking like something that we can easily find the cube root of that's close to the cube root of 29, because we're trying to approximate. We're trying to get pretty close to what the actual cube root of 29 is, right? We're trying to get really close to that. So we need something that's pretty close to 29. We need some number, right? That's pretty close to 29, but that we just can easily figure out the cube root of. So we use 27, right? 27 is pretty close to 29, and we can easily figure out the cube root of it, right? The cube root of 27 is 3, because 3 times 3 times 3 is 27. So our a is the thing, the just straight up number, just the straight up number, no, just a straight up number, not like a function or like a cube root or like a exponent or anything, just a single number, right? That we plug into our f of x that we can't, that we can figure out easily. And then our x is the number that we can't figure out easily, but it's kind of close to the number that we can figure out easily. And as you do some more practice problems, it'll generally make more sense, but just know that x is going to be the actual number that we're trying to figure out, and then a is going to be the number that's pretty close to the number we're trying to figure out, but we can actually find the answer easily. So then what we do is we plug it into this formula. So f of a, right, our f of x, here I'm going to color code it actually. So our f of x is the cube root of x. So our f of a will be the cube root of 27. And that's, as we said, just 3, right? Because 3 times 3 times 3 is 27. So then we need our f prime of a. In order to find our f prime of a, we need to first find our f prime of x. So that will be the derivative of the cube root of x. Cube root of x is the same thing as x to the 1/3 power. So the derivative of that would be 1/3 x to the negative 2/3, right? Basic power rule problem. You subtract 1 from the power, and then you drop that 1/3 down. And this can also be rewritten as 1 over 3 times x to the 2/3. So, if we want to find f prime of a, our a is, again, right, 27. So f prime of 27 equals 1 divided by 3 times 27 to the 2/3 power. 27 to the 2/3 power is the same thing as the cube root of 27. to the second power. And as we said before, the cube root of 27 is just 3. So that's 1 over 3 times 3 squared, which is just 1 over 27, because 3 times 3 times 3 is 27. So our f prime of a equals 1 over 27. So we've got that plugged in, or we've got that figured out. So now we just need to plug everything into the formula. And so this would be so I guess the proper notation for this would be cube root of 29 is approximately equal to our L, or our linear approximation function, of 29, which equals, and then we just straight up write this out. So f of a is going to be 3 plus f prime of a, 1 over 27, times x minus a. X is 29, our a is 27, so we could just simplify that to 2. And I forget if Dr. Naines asked you all to simplify that or not. I always said don't simplify that. I'm not sure if it would change based on if you had actual numbers, but you could simplify this to, at least for the quiz, right? You could simplify this to 2, and then even further to 2 over 27. But I would say the furthest I would recommend simplifying it would be to 2 over 27. But so something like that. Like don't simplify this any further. You know what I mean? So that's how you deal with a basic linear approximation problem. So, and once again, it just gets easier as you start getting some examples under your belt and stuff. It's really not too bad once you get rolling. So this would be another example. So, but I'd say this is definitely more the kind of problem you could expect to see on the quiz, where they don't straight up tell you what your f of x is. You kind of have to figure it out on your own. So, but it's relatively easy. It's just a pattern thing, or it's like, right, we need our f of x, we need our x, and we need our a. And remember, x and a are always just going to straight up be a number. And the x is always going to be a weird decimally number. So the only weird decimally number in here is 1.97. So what function is 1.97 being plugged into? You can kind of almost activate the chain rule part of your brain here and say, okay, this 1.97 is being plugged into the function x to the 4th, right? So our function is x to the 4th, and we're plugging in 1.97 into it to get this thing. So now, all right, we've got 1.97 to the 4th power. That's what we're trying to approximate, but now we need a value that we can plug in to this function instead of 1.97. That's pretty close to 1.97, but we can easily figure out what it to the 4th power actually is. So the way we do that is we just figure out a equals 2, right? 2 is very close to 1.97. We can easily figure out what it is to the 4th power. 2 times 2 times 2 times 2 is 16. So that's what we'll be working with. Just grab our linear approximation formula. We're going to be using this for every single linear approximation problem. If you don't know this formula, you will get a 0 out of 0 on every linear approximation question. You just have to know the formula. So f of a is going to be, we said our a is 2, so f of 2 equals 2 to the 4th power, which we said is 16. So, all right, we got this part checked off. How about f prime of a? So in order to find f prime of a, we first have to find f prime of x. This is our f of x. We just take the derivative of it, 4x cubed, right? Okay, so then f prime of a, we said our a is 2. So that would be 4 times 2 cubed. So then this would be 4 times, all right, 4 times 2 cubed is 8, so 4 times 28 is 32. And then finally, x minus a, x minus a, we said our x is 1.97, and our a is 2, so that is negative 0.03. So we just put it all together for this whole thing. So we would say f of, 1.97 to the 4th power is approximately equal to our linear approximation at 1.97, which is equal to 16 plus 32 times negative 0.03. And that would be sufficient. Okay, and then this is a previous quiz problem, probably about 2 years ago or something like that. But very similar to the last problem. We've got f of x, x, and a. We want to identify all three of those. Our f of x is our x, right? Our x is always the weird decimally number. So that's 8.12. It doesn't have to necessarily be a decimal, right? It just kind of has to be like arbitrarily close. So like, for example, if this was like, if you were trying to do 26, if you're trying to take the square root of 26, right? Or you were trying to use a linear approximation to estimate the square root of 26, then 26 wouldn't be a decimal, but the square root of 26 is a weird decimally number, so you definitely wouldn't be able to come up with that just off the top of your head. So your a would be 25, right? And your x would be 26. So it doesn't necessarily have to be a weird decimally number, but it's definitely a number that you can't just easily figure out. You know what I mean? So your a is the number that's pretty close to your x that you can easily figure out. So that number in this case is going to be obviously 8, right? Because we can figure out this 8. So f of x is going to be x to the 5/3 power, right? Because that's what kind of the function that we plug 8.12 into to get 8.12 to the 5/3 power. Okay, so then let's copy paste our formula once more. Okay, so then now f of a, so we just take our f of x and we plug an a into it. So we said our a was 8, so f of 8 equals 8 to the 5/3 power. That is going to equal, so remember when we have fractional, or if we have like a fractional exponent, we can start with the denominator as the root. So, right, 8 to the 5/3 is the same thing as cube root of 8 to the 5th power. Cube root of 8 is 2 and then 2 to the 5th power is 32. So f of a is going to be 32. F prime of a, right, to find f prime of a, we must first find f prime of x. So it's going to be 5/3 x to the 2/3 power. Basic power rule problem, drop the power by 1. So then we just need to plug in a to that. We said our a is 8, so that's 5/3. 8 to the 2/3. That's 5/3 times 2 squared, which is 20 divided by 3. Oops. So that is our f prime of a, and then x minus a is just going to be 8.12 minus 8, so that's going to equal 0.12. So then we just plug it all in. 8.12 to the 5/3 power is approximately equal to our linear approximation of 8.12, which equals 32 plus 20/3 times 0.12, right? Just plugging all the shit into this formula. And yeah, that's what we end up with. Okay, then this, so I honestly, for my money, I would guess that you would see one of these types of questions, just like number 2 or number 3. But number 4 is, I just want to cover the bases, right? So you guys are able to see everything, right? Because you don't want you to be thrown for a loop. But so there is this way of doing it, and that's right, you just got to remember it's the same formula every time. You're given the f of x here. Our f of x is square root of 22 minus 3x. And it's telling us to use the base point x equals 2, so that is telling us our a equals 2. So, and we're going to use it to approximate this. So if a equals 2, right, then our f of a equals this, right, where we just plug in 2 where we see x. So f of a equals square root of 22 minus 6. So f of a equals square root of 16, which equals 4, right? So if we are going to our formula now, our f of x is this. So our f prime of x, sorry, don't want to erase that. So our f prime of x is just the derivative of that. That's a chain rule problem, right? So here, I can first rewrite it as 22 minus 3x to the 1/2 power. And the derivative of that would equal 1/2 times 22 minus 3x to the negative 1/2 power times negative 3. And then, so that would equal negative 3 divided by 2 square root of 22 minus 3x. And then f prime of a would equal negative 3 divided by 2 times so we said our a is 2, so f prime of 2 equals 22 minus 3 times 2, so that's negative 3 divided by 2 times 22 minus 6 is 16, so negative 3 divided by 2 times square root of 16, square root of 16 is 4, so that's negative 3/8. And so then the last piece of the puzzle is the x minus a term, right? It goes right here. But notice we identified our a, but we haven't identified our x yet. So our x, remember, is a number, weird decimally number that's pretty close to a. So we got to figure out an x that's close to a. So if we plug in, or if we set the inside of the square root, right, 22 minus 3x equal to 15.976. That is, and we subtract 22 from both sides. then we end up with negative 3x equals, what is that, a negative 6.024. So then we divide both sides by a negative 3, and we get x equals 2.008. So our x equals 2.008. So then we plug everything into the formula. F of a, so our f of a is, right, we said 4 plus f prime of a, so that would be negative 3/8 times our x is 2.008 minus our a, which is 2. So that will be our final answer. All right, and then finally, the last thing I want to talk about with respect to linear approximations is differentials. They're kind of like linear approximations, but just like weird. So basically, it's mainly used in the approximation of error with respect to like measurements and stuff. So if we have the surface area of a cube and we want to figure out how much a mismeasurement with respect to one of the sides of the cube could affect the surface area of the cube, we would use this formula. So if we take our formula for surface area of the cube, and that's 6a or 6s squared, where s is the length of one of the sides of the cube. So we take the derivative of that. So the derivative of the surface area with respect to the side is going to be 12s, right? So now differential basically says, all right, so you move that ds over. So you multiply both sides by ds, essentially. So dsa equals 12s times ds. And the ds, right, is, right, d anything is really just however much that thing changes, right? So this changes plus or minus 0.1 inches, right? So our ds is 0.1. So, and then our s is 5 inches, right? So s equals 5, ds equals plus or minus 0.1. So, and we're trying to figure out our DSA, right? Because we're trying to find the range of the surface area. So DSA equals 12 times 5 times plus or minus 0.1. So DSA equals, what is it, 60 times plus or minus 0.1. So DSA equals 6 or plus or minus 6 inches squared, because surface area would be squared. So that would be our answer there. All right, so now moving on to inverse trig, which is the second thing that's going to be on this quiz. So there's really two parts of this. There's the identities and then there's the derivatives. So the identities is just another way that you can write the inverse trig stuff, and then the derivatives are going to be like anytime you're actually asked to take a derivative where the inverse trig function is involved, that's when you use those. So these first two questions are going to be identities. So these are just alternative ways that you could be asked to write these. So for cosine, right, so first there's sine hyperbolic, which equals e to the x minus e to the negative x, all divided by 2. And then there's cosine hyperbolic, which is e to the x plus e to the negative x, all over 2. So for this particular question, we're being asked about cosine, so that is going to be e to the x plus e to the negative x, all over 2. And we're asked to plug in ln of 5 there. So that's going to be e to the ln 5 plus e to the negative ln 5, all divided by 2. And really the crux of any problem that you're going to be asked of this nature is going to be that the e and the ln cancel out, right? The e in the base cancels out with the ln in the exponent, and what you're left with is just the whatever's left. So that's going to be a 5 in the case of this, and then a negative 5 in the case of this. So this is going to be 5 plus negative 5 divided by 2, which is going to be 0 over 2, which is 0. If this was, say, sine hyperbolic of ln 5, right, then it would be e to the ln 5 minus e to the negative ln 5 all over 2. Same thing would happen here. So here we'd be left with 5 minus a negative 5 all over 2, which would be 10 divided by 2, which would be 5. So that's how you would approach that kind of a problem. Stepping up a little bit in difficulty, we want to prove that cosine hyperbolic plus sine hyperbolic equals e to the x. So we recall that cosine hyperbolic has the plus, and then sine hyperbolic has the minus. So let's just get into it. So e to the x plus e to the negative x divided by 2 plus e to the x minus e to the negative x divided by 2. These both have 2 as a denominator, so we can combine them into one fraction. So we can rewrite this as e to the x plus e to the negative x plus e to the x minus e to the negative x, all divided by 2. So we can say, okay, this plus e to the negative x cancels out with this negative e to the negative x. And these two e to the x's combined to give you 2 e to the x, right? Because e to the x plus e to the x is the same thing as 2 times e to the x, all divided by 2, and then these two 2's cancel out to give you e to the x. So that would prove that identity. Okay, so then something with the derivatives, and right, this is, I'll just show it to you now. These are the derivatives, right, that you have for hyperbolic trig. It's really just the same as your regular trig derivatives. I know you've recently had to, or been responsible for knowing all of your inverse trig derivatives and shit like that, and you're probably like, another set of trig derivatives, man, that sucks. And I mean, you're kind of right, but it's really the exact same thing as the regular trig derivatives. So if you have your regular trig derivatives, you're going to be totally fine. The only curveball is with this sine and secant. So I'm sorry, with cosine and secant. So with cosine and its inverse, which is secant, you just have an extra negative sign. So like, you remember how in regular trig the derivative of cosine was negative sine. So but now you kind of pick up another negative, so that becomes a double negative. So instead of being negative sine, it's now positive sine. And then same thing over here. The derivative of regular secant was secant tangent. Now it's a negative secant tangent. So you kind of just pick up an extra negative. Everything else is really just the same. You just got to remember to throw in that h, right, for hyperbolic, but I mean, the derivatives are the exact same. So you could be asked a regular derivative problem within the context of this stuff. So that would look something like this. So this is just a basic chain rule problem. Didn't mean for it to be too difficult, so let's just go through it. So this is, right, our function, our outside function is tangent hyperbolic of x, and our inside function is 9 to the x. Derivative of tangent hyperbolic is secant hyperbolic squared of x, and then the derivative of 9 to the x is 9 to the x times ln 9. So then we just put it all together in the form of f prime g of x times g prime of x, and we get secant hyperbolic squared of 9 to the x times 9 to the x ln 9. And then, all right, so that is our first term. And then our second term, right, our f of x is tangent x. Our inside function is 3x. Derivative of tangent x is just secant squared x. Derivative of 3x is just 3. So that will be plus secant squared of 3x times 3. So that'd be our final answer there. Finally, the last thing is going to be maxes and mins. So I would encourage you to just look back at the lecture notes on 4.1, because there's some stuff about Fermat's theorem and then another Fermat's theorem that may or may not be relevant on the quiz. This Fermat's last theorem thing seems like trivia. I could see it being on maybe the exam or something. It would be hard to work into a question, that's for sure. So Fermat's theorem just says that the only places that local mins and maxes occur are at critical points, and critical points are just when the derivative is 0 or when the derivative does not exist. So that's going to be relevant information for us here. The extreme value theorem says that on each closed interval, you have an absolute min and an absolute max. So basically, when you see this kind of question, you need to be thinking about two things. You need to be thinking about your critical points, and you need to be thinking about your endpoints. So let's start with critical points. Make this one blue and the critical points orange or yellow. So the critical points, right, we said f prime of x, or I guess in this case g prime of x. G prime of x equals 0 or g prime of x equals dne, either 0 or dne. So first let's find our g prime of x, right? That'd be a good start. 2x minus 4, right? Pretty simple derivative right there. So now we get this doesn't dne anywhere, right? There's no denominator to give it a vertical asymptote. There's no like logarithm or any of that weird stuff. So it's just, so we can just set it equal to 0. Add that 4 plus 4. 2x equals 4, so x is going to equal 1/2. That's our only critical point, right? Because that's the only value that makes our derivative equal 0 or dne. So we have, and then the other thing we need to think about is our endpoints. So basically, you compile these like this list of x values, right? You get all your critical points, which in this case we only have 1, and then you grab your two endpoints, which is -1 and 4 in this case. And you plug them all into your regular g of x, and whichever of them has the highest y value is going to be your absolute maximum on the interval, and whichever of them has the lowest value is going to be your minimum on the interval. So let's just plug in 1/2 here and see what we get. So g of 1/2, we plug that in, we get 1/2 squared minus 4 times 1/2. So that's going to be 1/4 minus 2. So that will be a negative 7/4. Yeah. All right, so we got negative 7/4 there. And then now for our endpoints. So we got -1 and we've got 4. So now we need to plug those in. So g of -1, that's going to be -1 squared minus 4 times -1. So that's going to equal 1. And that's going to be a double negative, so that's going to be a plus 4. So that's going to be a 5. And then our other endpoint is going to be 4, right? So that's going to be 4 squared minus 4 times 4. So it's going to be 16 minus 16, which is going to be 0. So now we've got these three y values. We've got 5, 0, and -7/4. So the highest, or the greatest of these values is going to be our absolute maximum on this interval. And that is going to occur at g of -1. So we would say absolute max of 5 at x equals -1. And then for the min, we would take whichever of these has the lowest value, which is going to be that -7/4. And then we would say that we have an absolute min of -7/4 at x equals 1/2. So that would be our final answer there. So, and if you were asked to list the critical points, we would list this as our only critical point, right? The point 1/2 comma -7/4. That would be in response to the question, list the critical points. This question, a little more challenging, so but really the same exact thing. So right, we got our critical points, and then we've got our endpoints. Start with our critical points. So in order to find our critical points, right, our derivative has to equal 0, or it has to DNE. So let's take the derivative first. 12x to the third power minus 12x squared minus 24x. We want to set this equal to 0. And, oh God. So we'd factor a 12 out. Sorry, we'd factor a 12x out. So then this would be x squared minus x minus 2x equals 0. So we could factor that. This would be x, negative 2, and 1, negative 2x, x. So this would be 12. This would factor to 12x times x minus 2 times x plus 1 equals 0. So then, right, what makes this whole thing 0 would be what makes any of these individual 3 terms equal to 0, right? Because then it would be 0 just times 2 other things. So that would be x equals 0, x equals a positive 2, or x equals negative 1. So those are our 3 critical points right there. So now to, sorry, let's make this purple. So now we got to figure out, so now we've got 5 candidates, right, for absolute max and absolute min on this interval. We've got our 3 critical points, and if you were asked to list the critical points, you would plug all 3 of these x values back into our regular f of x, and then you'd list them as ordered pairs, just like we did for this right here. But if we were trying to find the absolute max or min, we would have to take into account these 3 critical points and then also these 2 endpoints. So let's start by finding the x values of the critical points. X equals 0, that's pretty simple, right? F of 0, you just plug in 0 for everything here. You're left with just that 1. So we've got 0, 1. For this 2, that would be 3 times 2 to the 4th power minus 4 times 2 to the 3rd power minus 12 times 2 squared plus 1. So that would be 3 times 2 to the 4th power is 16 minus 4 times 2 to the 3rd power is 8 minus 12 times 2 to the 2nd power is 48. And then plus 1, so that will be 30, no, that'll be 48 minus 32 minus 48 plus 1. These two 48s cancel out, so you're left with a negative 31 there. So f of 2 equals negative 31. We've got to figure out negative 1. So if we go and we plug in negative 1, we get 3 times negative 1 to the 4th power minus 4 times negative 1 to the 3rd power minus 12 times negative 1 to the 2nd power plus 1. So that will just be 3 plus 4 minus 12 plus 1. So that will be negative 4. So f of negative 1 equals negative 4. So then now we have to figure out our endpoints. So we've got f of negative 2, our left endpoint, right? So that'd be 3 times negative 2 to the 4th power minus 4 times negative 2 to the 3rd power minus 12 times negative 2 to the 2nd power plus 1. So that equals, all right, so negative 2 to the 4th power is no, sorry, 16. So 3 times 16 minus, or actually it would be a plus because we'd have an odd power. So that'd be negative 2 to the third power is going to be negative 8 times 4 is going to be 32. And then negative 12 times negative 2 squared, that will be a negative 48. Because negative 2 squared is 4, and then plus 1. So equals, what is that? 48 plus, oh, well, these two 48s cancel out. So we're left with 32 plus 1, so that's 33. So we get 33 for that one. And then for f of 3, we get 3 times 3 to the 4th power minus 4 times 3 to the 3rd power minus 12 times 3 to the 2nd power plus 1. So this will go 3 to the 4th power would be 27 times 3, which is 81 times 3. Oh my god. This was an actual test question. 243 minus 4 times 27. 108 minus 12 times 9, 108 plus 1. Oh my god, those 108s don't even cancel out, do they? Oh, well, I guess so that's 243 minus 216 plus 1. So that is 244 minus 216. God, what is this? 3, 14, 8, 2. So that's 28. So f of negative 2 equals 28. All right, so now I'm going to circle all the shit. Or box it, whatever. All right, so these are our 5 candidates for absolute maxes and mins. The greatest of these 5 will be our absolute max on the interval, and the least of which will become our absolute min on the interval. So for absolute max, what is the greatest y value we have here? It appears to be 33, and this occurs at x equals negative 2. Then we have an absolute min of what is the lowest y value on this interval. It appears to be negative 31 at x equals positive 2. So that would be our answer there.